static constructor. So we talked about all these things here. What? Static methods, static fields, and also static constructors. All the three things I just been shown you basically. All the things, static, non-static, for everything we have been learned about it. Now, we have static classes also, guys. I did not show you. We have static classes also. What's a static class? Nothing to talk about a static class. A static class can contain only static members in it. Cannot contain any non-static members. Every member of a static class is going to be a static member. Every member of a static class is going to be a static member. Cannot contain any non-static members at all. So it is basically a combination of static members. All the static members combined together into one class, we call it as a static class. And remember, you cannot create the instance of the static class at all. And moreover, not required. Why not required? When every member is static, instance is not required. Do you understand my point? When every member is static, instance is not required. You don't require an instance when every member of the class is going to be a static member. So straight away, instance creation, without instance creation only, the code gets executed for you. So that's what a static member is. Are you clear that what a static class is? And remember, a best example for a static class is console class. Console class is a static class. Yes, guys, console is a static class. Every member of the console class is static only. Every member of the console class is static only. You can see that how. Well, guys, you can see the contents of any predefined class. You can see the contents of any predefined class. Okay? How to see the content of the predefined class? Say, you right click on the class, and you will find an option called go to definition. Go to definition. When you select it, it will show the metadata of that class. Metadata means it won't show you the contents. It won't show you the logic. It will show you the signatures of what is present in the class. See here? Look, this is a predefined class. And this class is a static class. It's a public static class defined under system namespace. And these are all the members of the class. See? So many members of the class. Look from top to bottom. Everything is static only. Are you clear? Everything is static only now. Okay? So you can see the complete, this is called metadata. Metadata in the sense, it won't show you the contents, but it won't show you the logic, but it will tell you these are the contents in it. If you expand any member, it will give you a description telling you what input it takes, what result it gives to you, what errors will come in this, all the information. Just this is only called metadata. Is everyone clear? I'm talking with you online. Understood? So this is called as metadata. It's just going to show you the metadata of the appropriate class. It is going to show you the metadata of the class here. No sir, I want to see the source code. I want to see the source code of this particular class. Can I see the source code of the class? Yes. My .NET is open source. You can also see the source code, but not here. All the source code of all these classes are hosted under GitHub. GitHub is a central repository. Generally today every company will host their patents. If there is open source, everyone is given free access. If it is not open source, you require a login access. So GitHub is a central repository. All the companies are today putting their source code. Understood? Tomorrow you work in a company now. See, tomorrow when you're working in a company, today what is going on? Work from home culture is going on. 100 people are working on a project. How do they share the code with each other? All the code is put in one central location called as GitHub. Understood? So GitHub, it will be on the GitHub. So what you will do, you will be uploading, you are pushing your everyday whatever changes you make, you will be pushing up your changes to GitHub. That will go to GitHub. Tomorrow other people can get that particular changes onto their system. So that is just a central repository what we have. So Microsoft has posted all the source code of it in the GitHub. Okay? So tomorrow your company also will put on the GitHub only. Only difference is Microsoft has given open source. So no need login. Directly anyone can access it. But your company is not open source now. So they don't give the source code to other people. So you will be having a login access. Only when you are login, then only you will be getting access to it. Are you clearer or not? Okay, that will provide you only login access, but general access is not going to be given for the general public here. So if anything is open source, free access. So right now .NET is open source only. Because it is open source, guys, just open Google and search for console class source code. C# console class source code. C# console class source code. Just type it. It will provide you the GitHub reference. github.com, the reference it will give you. And when you click on that, it will open and it will show you the complete source code of the class. This is the source code of the class. Do you remember? I said to you, what is the purpose of the class? The class provides access to the standard input, standard output, and standard error states. I already said here, it's a class which provides a set of members to perform IO operations on the IO devices. Only it is telling you. And by default, see that imports so many namespaces. That imports so many namespaces to you. And root is system. Basically, namespace importing. Just a minute, I will show you. Namespace importing, where we do, guys? On the top of the class we do now. If you want, you can do it like this also. Understood? Like that also we can write. Actually, general scenario is right on the top. But if you want, you can put everything in the namespace. Inside the namespace also we can import that. No problems. But I suggest you following this approach. Okay? So that only. Here see. Namespace system. Under that, all the namespaces are imported, and then it is going to give you the contents, whatever is defined in the class, everything is showing you. See, it has few constants in the code. It has few constants in the code, see. Okay, they're all constants. They're all going to be constants what it has. And also some static fields. Some static fields it has. Okay, it's going to have some static fields. Like this, if you just go down, you'll be finding up all the methods, write line, read line, everything, whatever we are using every day, all the methods will be available for you in this. It's the complete source code. Understood? So that's what open source means. Open source means the code is free for everyone to access. Everyone can access the source code. Just a search in the Google, it will provide you a GitHub link, and you can just click and just see the GitHub code, what is present inside of. Actually, the class contains 2,304 lines of code. Totally everything what is defined in the class. 2,304 lines of code is present for you inside of. Am I clear on all of you? Okay, so this is about see, remember, we shown you a method, string format, params object array. I explained you, so params object array like this, it is just going to pass on the things. So it will print you all the values. Okay. So whatever it is, we can just see this is the complete source code of this. So the best example for a static class is console class. Okay. So console is a static class. Nothing more to talk about a static class here. We learned static fields in detail, static methods in detail, static constructors in detail. Put all these three in one class, and that class is a static class. No need to create the instance of the class, and we cannot create the instance of the class also. Static class instances cannot be created. We cannot create it, and we don't require to create it also. These things are not going to be possible. So this is about, this is all about static classes, static methods, static fields, and static constructors. Okay, so today guys, I'm going to teach you, today I'm going to demonstrate about a concept to you, what it is. Yeah, as I promised you, I said you, I'll tell you a case study, how applications will be designed and running for you in the real time. We'll talk about a small case study about in ATM systems, how ATM systems are functioning in the real time. Okay, I'll tell you. But before that, I'll ask you a small question. Guys, you might be learning about DBMS in your academics. You might be learning about DBMS in your academics. Might be coming across DBMS in academics. So can anyone answer this question? In DBMS, what does a table represent? What's a table? Did not ask you what is database management system. What is table, I asked you. What's a table? Rows and columns. Athar Khan, I did not ask you what does the table contain in it. You're telling table is rows and columns. I did not ask you what does a table contain. My question is, what is a table? Or other way, what a table represents. Structured. Storage of data is the purpose of the table. Data in tabular format. You're giving how it looks. My question is different and what you're answering different. I'm asking who are you, and you people are telling I am 5 feet 6 inches height, my color is pale. That's what you're telling. Who are you? Tell that first. I asked you what is a table and you're going database. Database is on the top of the table. What does it represent? What does a table represent? Particular. Is it what you learned in the DBMS? Shame on your part here. So many of you coming from engineering backgrounds, computer backgrounds, computer engineering backgrounds. Don't know what is a table. It represents an entity here. That is the answer. Table. Who asked you what it contains? You're telling rows and columns and all the nonsense. What's a table? A table is an entity. That is the answer what you should give. Go and read your DBMS notes, textbooks and find out what it will tell you. A table is a entity. What's an entity? Any living or non-living object, associated with a set of attributes is called as entity. We use tables to represent entities. So what's an entity? Any living or non-living object associated with a set of attributes is called as an entity. Can I call a pen as an entity? Yes, you can call a pen an entity because pen is a non-living object, but it has a set of attributes. What attributes? The weight of the pen, the size of the pen, the color of the pen, the model of the pen, the price of the pen. All these are the attributes of a pen now. Can I call a mobile phone as an entity? Come on, faster. Can I call a mobile phone as an entity? Yes, you can call a mobile phone as an entity. Okay. Can I call a student as an entity? Can I call an employee as an entity? Basically, a table represents that only. A table represents entities. Is it clear? Okay. So, tomorrow, guys, remember, all of you, when you start working in the real time tomorrow, always you guys, you'll be referring to the entities only. You'll be working with these entities only. When you start working in the real time environment, always remember, you'll be working with these particular entities only. You'll be dealing with the entities only always. You catch my point or not? What is that? You will be dealing with the entities actually. Okay? So, if you follow my point here, so what is the dealing with entities? Will be right out. What is the dealing with entities only? Yes, guys. You're developing an application for a school. So, you'll be dealing with few entities in the school now. Who are the entities? Student, teacher, staff. Student, teacher, staff. You're developing an application for a bank. Who are the entities? Customer. Customer is the entity. Employee. Customer and employee. You're developing an application for a business concern. Customer, employee, supplier. Who supplies the goods to him? Are you clear? You're developing an application for a grocery. So it has mainly three entities here. One is customer. Second one, supplier. Third one, employee. All these are the entities in this. So every application mainly deals with entities. So tomorrow, if you are building an application in the real-time environment, you need to follow a series of steps to build application. Step 1. Identify the entities that are associated with the application. Identify the entities that are associated with your application. What entities are present in the application you are required to identify first. Step 2. Identify the attributes of each entity. Identify the attributes of each entity. Every entity will be having a set of attributes now. You're required to identify the attributes of each and every entity. What attributes are present for every entity, you should identify. Okay? For example, you are building a school application. So what is step 1? Identify the entities associated with this application. Guys, tell me. Student, teacher, staff. Step 2. Identify each entity. Okay? So you observe. If you observe, so the first thing is student. What are the attributes? ID, name, address, parents' contact number, okay, parents' phone number. Next, parents' email ID, okay. Apart from this, in which class the student is studying, what is his section, what is his fees details, all the information. Same way, there is a teacher. Every teacher has a ID, every teacher has a name, every teacher has a address, phone number, and teacher also will have an email. Apart from this, what is the subject the teacher deals with? What is the qualification of the teacher? What is the salary he get? Okay, same way we have a staff. Staff basically non-teaching guys. Teacher is also staff, only teaching staff. Staff means non-teaching, clerks, accountants and all these people. Okay, for them also. ID, name, address, phone, email. Apart from this, what is his job? Okay, and whom is going to reporting to? What is his department? In which department is working? What is his salary? Some attributes will always be common, guys. Some attributes will always be common. Did you notice in all these three, ID, name, address, phone, email are common for all? Apart from that, you're just asking for class, section, fees. Suppose if you talk about a student, today the student, they may be asking a Aadhaar. For a student, they may be asking a Aadhaar. Okay? And for a teacher, they may be asking a Aadhaar and also a PAN. What's a PAN? You require to update your PAN also. Clear? So something required for one, something may not be required for the other. Okay? So today, what is it? Aadhaar is mandatory for everyone. For everyone, Aadhaar is mandatory. But will the student have a PAN card? A student doesn't have a PAN card. A student doesn't have a PAN card. Okay? So PAN is specific to a teacher. Okay? And again, here also, what I said, Aadhaar required for him also. And this person also may require a PAN card. It is a low income generation because a clerk is there. An office boy may not have a PAN card. Okay? So, chances. Like we are just going to store up the information required for each and every of the person like this. So, this is what we just do. Are you clearer, guys? Yes or not? So here, not only this one, class, section, fees. Next, what are your marks? What are the marks the student attained? What is his grade? Which grade? A grade student, B grade student? I just want to store all these things. Clear? So like this, we are going to have some data specific to the appropriate employee. But some attributes are going to be very common to all people. You know? Yeah. Are you clear with first and second steps now? Now comes the third step. What is the third step? In the third step, guys, what we do, you know? In the third step, what we do is design a database. We design a database actually. Okay? And in this process, every entity we have identified will become a table under the database. Are you clear what I said here? Array. So you have three tables now: student table, teacher table, staff table. Now that's what I said here. Table represents the entity. So you have three tables now: student table, teacher table, staff table. Three tables will come. Okay. So in this process, every entity will have, we have identified will become a table under the database. Okay. Next, every attribute we have identified will become a column under the table. So now student table is there. What are the columns of the student table? ID, name, address. All these are the columns in the table now. Clear? These are the columns in the table now. Okay. Next, each and every record we insert in the table will now be a unique identification per entity. See, each and every record we insert in table will now be a unique identification for the entity. See, in the student table, we inserted 100 records. 100 records represents 100 students, or less than 100 or more than 100. Louder. 100 represents 100 only now. There is no chance to be lesser or more also. Lesser chance is not there. More also, there is no chance. Why? Duplicate records we don't insert now. So 100 means 100. Are you clear? So remember guys, a table is an entity. A column is a attribute. A column is a attribute. A record is a unique representation for the entity. Okay? So just in the third step guys, we'll be designing the database. In the third step, we'll be designing the database. Design a database, and in this process, every entity we have identified will become a table under the database. Okay, will become a table under the database. Okay. Just a minute. In this process, every entity we have identified will now become a table under the database. Every attribute we have identified will now become a column under the table. And third one, each and every record we insert into the table, into table will now become a unique identification for the entity. Okay, so these are the things now. Now database is ready. Now database is also ready. Tell me guys, can the end user or otherwise, will you give a direct access to the end user for the database? Will you give a direct access for the end user to the database? No. Will a bank give access to the database? No. So in the fourth step guys, what you require to do, develop an application by using some programming language, by using a programming language, by using any programming language, and this application should work as an UI. UI means user interface between the database and are you clear? You are not interacting with the database directly. Remember, you are provided with an application. The application interacts with the database. The The application will be sitting between the end user and the database. Okay? To build this application, we follow the below guidelines. To build the application, we follow below guidelines. Okay, what are the guidelines? Next, define a class to represent each entity. What you do now? Define a class to represent each entity. Now, we are going to define student class. We are going to define a customer class. We are going to define, student class, a teacher class, and staff class. Staff class. Okay, next. Define a property under the class where each property represents an attribute of the entity. Property means field here. That's all. Property means a field. Where each field should be representing each entity. Okay? And finally, now create instances of the class where each entity should be a unique representation for each entity. Unique representation for each entity. These are the guidelines what we follow. So what I'm finally trying to tell you now, guys, a table in the database and a class in our application both are same. Got it? A table in the database and a class in our application both are same. And both are used for representing entities only. We use tables in relational programming to represent an entity. We use classes to represent entities in object-oriented. And if at all you talk about procedural programming languages like C, we used structures to represent the entities. Recollect yourself, in the C language you learned structure. Struct student. So struct student represent the student entity now. All are same, guys. Just the standards are going to be a little bit different. We use tables in relational. We use classes in object-oriented. We use structures in procedural. Okay now? Next, second point. A column of the table is exactly same as a property of my class. A column of a table is exactly same as a property of my class. Columns of the table. We have columns in the tables. Every table has a column and we define it in the form of a property. Both are same. Both are used for representing attributes of the entity. Both these two are used for representing the attributes of an entity. Third, a record in the table and an instance of our class both are same. Both are used for a unique representation of the entity. If you want, read the first point on the top and read here. See, this point here and this point here. Come on. First, second, third, both are matching. See, read it. What's it telling you? Every table will be entity. Here what is it telling you? Right? Define a class to represent the entity. Second. What is it telling you? Every attribute will now become a column, so add columns. Same point, the second one is also telling you. What is it? Define a property under the class where each property represents an attribute of the entity now. Third. Is it clear? Okay. So that's what. Now what you do? We just go for defining the attributes like this in classes. So this is what we're just going to do. Okay now? So that's what. Here every record we have and here every instance we have. Both are same. Are you clear? So tomorrow when you start working in the real time, this is how you work. So don't forget this one. All these things will be very, very important for us when we jump start with the database programming. When we start with database programming, we'll do all these particular things. We'll create the tables there and we'll define the classes here. So these classes will have tables in the application. Okay, for example, that's very advanced right now, but I'm showing you. Watch. How the application development will be present tomorrow, you can just watch this. This was a live example. Basically, you'll be learning all these things in the data stages. What is my class name? Louder. Supplier. And basically, these are all the attributes of my class now. What's it? ID, name, ID and supplier name. Here, balance, customer name, address, customer ID. Like this, we just have SID. These are all the columns. These are all the columns. So you remember what are the entity names now? One entity is customer, one entity is supplier. Now, if you come to your database, in my database, check. Represents the customer there. Represents supplier. Supplier has only two attributes, remember? What are the two attributes? SID and name. And customer has multiple attributes. What are these? ID, balance, name, address, SID. Matching or not? So tables and classes. So in our application, we don't deal with tables. We deal with classes. When we deal with classes, those classes will be inserting the data into the table, updating the data in the table, deleting the data in the table, selecting the data from the table. We don't write SQL statements anywhere. We all write purely some object-oriented coding, and that will do the database operations to us. So this application is a UI. So end user tomorrow talks with my application only. End user doesn't talk with the database. When the end user talks with the application in turn talks with the database basically. Are you guys clear? Okay. So this one what I shown you is a batch which is going to be completed. You are still in the starting stages only. But going forward, that will be how the applications will be generated or applications will be developed. We are learning the standards basics for. Going forward, we will also build those applications. By end of the course, you'll be ready to build applications in the architecture what I explained to you right now. That is what exactly we follow in the industry as of now. Is everyone clear? There is only response from one student. Or other sleep alive or sleeping? So Yasmi is sleeping, huh? Okay. So that's what exactly we just do, guys. Now see, the bank has approached me asking me, can you please develop a application for using in my ATM systems? Bank came to me, just requested me, please develop an application so that we can use that application in our ATM systems. This is what they came out with. I said, okay, I'll do it. I'll develop an application for you so that you can use this application in your ATM systems. Okay, so what's my job now? My first job is to identify the entity. Step 1, identify the entity. Guys, here there is only one entity. You're building an application for ATM. Only one entity. Who is that? Customer, guys. ATM deal with only customers. ATM doesn't deal with employees. Right? So customer. Step 2, attributes. So many attributes, guys. Let us not take a lot of attributes now and confuse yourself. Few things I'll take. One important customer ID. Second one, name. Third one, balance. And guys, so many attributes will come. Just I'm giving you a simple idea, that's all. So that going forward, we can increase the number of attributes. Okay? Next, step 3. What is step 3? In the step 3, you're required to design a database. You're required to design a database. Design a database and create the table under it. Design a database and create a table under it. Okay? Now guys, you have a database called as bank database. You have a database called as bank database. In this database, in this particular database, you're just going to have a table called as customer. A table called as customer with so and so columns. What are the columns? Customer ID, name. Customer ID, name and balance are what you are just going to have. Okay, now the customer ID, name and balance. And now you start storing the data into the tables. You start storing the data into the tables. 101. 5,000. 102. Name is something BBB. Balance 15,000. 103. 25,000. 104. 35,000. So like this, we're just going to have some data in the tables. Okay, now? So we're just going to have some data in the tables like this. Yeah, we have the data in the tables now. Fine, well and good. Now guys, after looking at this code, after you just check out this one. You have the appropriate tables created. Everything is ready. You have the appropriate tables created and everything is ready right now. Okay, fine. And now, people understand me, I think. What's it? Step 2, step 1, 2, 3 completed. Step 4. In the step 4, what did I say? In the step 4, you're just going to define the classes. In the step 4, we are going to define the classes. Okay? Step 4. Develop an application that access an UI. Develop an application that acts as an UI. It's going to act as a UI. Okay now? So what to do? You need to define a class now. You need to define a class now. Class. What a class